Hey guys, welcome to this edition of College Algebra Fundamentals. And so we are starting in Chapter P, which is prerequisite material for algebra and trigonometry, for college algebra or whatever. And as you know, we use the Blitzer textbook. And so I'm going to go through and kind of just take you through some of the sections. We're going to start in section 4. If there are some things in the previous sections 1, 2, and 3 that you're still not sure about, my math lab should help you work through those. Those obviously are things that, again, you're expected to know, but it doesn't mean that I can't help you with it if you need it. But for right now, we're going to work on just polynomials, P4, and we're going to talk about the basics of polynomials, how to add and subtract them, how to multiply them, use the FOIL method, and things like that. Okay? So with that in mind, the definition of a polynomial looks a lot worse than it really is. A polynomial is simply a expression in which we have powers of x, and these are positive powers of x, and these are integer powers of x. So we don't have any fractional powers and we don't have any negative powers if it's a polynomial. There's no square roots of x, there's no x's in the denominator, none of that. It's just a sum of numbers. A sub n represents real numbers. They're called the coefficients, and a sub n is the coefficient of x sub n, x to the n. A sub n minus 1 is the coefficient to x to the n minus 1, that kind of thing. All right, and it's that simple, and that's what a polynomial is, and we deal a lot with polynomials in college algebra. We will introduce some other types of expressions, but we'll deal with polynomials for the first couple of chapters. Okay, and so in standard form, we typically write it with the powers going down. You don't have to. I mean, if you have x cubed plus 3x squared minus 4x plus 9, that's the same thing as 9 plus 3x squared minus 4x plus x cubed, right? These are the same because they're the same numbers with the right signs, but this is what's known as standard form, and that's the way we will typically write polynomials. Make sure that when you're inputting your answers into my math lab, if they ask you for standard form, you need to put it in that order, right? Descending powers, highest power first, and then all the way down, because it'll get a little bit picky about that. Okay. If you want to add and subtract polynomials, the important thing to do is you add and subtract like terms, and like terms are simply terms that have the exact same variable factors, the exact same. So same variable, like x or y, and same power of that variable. So x squared and x cubed are different types of terms, okay, for example. So if you want to add and subtract these polynomials right here, if you want to add these polynomials together, you'll notice that we're going to take the x cubes and put them together, negative 16x cubed plus 16x cubed. All right, we're going to take the x squareds, put them together, 4x squared plus negative 3x squared. All right, which is subtracting. Negative 11x plus 3x, we're going to put the x's together, and then we're going to put the constants together as well, negative 5 and negative 15. And so we group those together, and then we add the coefficients. Negative 17x cubed plus 16x cubed is negative 1x cubed. 4 minus 3x squared is 1x squared. Negative 11 plus 3 is 8x, negative 8x, and then negative 5 minus 15 is negative 20. Technically, what's happening here, guys, is if you take a look at the x squareds, you have an x squared in common to both of these, and so you can factor out the x squared, and you're left with a 4 minus 3, and then 4 minus 3 is 1, and that's why we have we don't write a 1 typically, right? But in this case, just to emphasize it, we're writing a 1 here. All right, but we don't need that. And that's the way it works each time. Okay, so technically what you're doing when you're adding like terms is you're really factoring out the likeness, the x squared. That's why you can't add 4x squared and 3x cubed, because it wouldn't work. They're not exactly the same. Okay, now when you want to multiply two things, then you need to know two parts of that. So to multiply monomials, remember monomials have only one term, you want to use the properties of exponents. These are things that you should already know. This is back in section 3, so P3. So if you don't know that, you may need to take a look at those, all right, again. And so what does that mean? So when you're multiplying two polynomials, then if we have like 3x cubed times 4x squared, what we do is we group the constants together and the x's together, all right? And then when you're multiplying x's, what happens, right? So this is what's known as the commutative property. Remember, these are multiplied also. And so when everybody's multiplied, you can change the order. So I multiply the constants, 12, 3 times 4. And then what happens with the x's, I have 3 x's and 2 x's, so I have x to the 5th total. I add the exponents. When I'm multiplying two powers of x, I add the exponents, so you get 12x to the 5th. Okay, so that's how you do it when you're doing monomials. If you want to do something a little bit more complex, all right, like multiplying a binomial times a trinomial, okay, notice what they've done. They've done kind of the double distributive property. They've said, okay, 5x gets multiplied by all these guys, right? And then negative 2 gets multiplied by all these guys also, all right? And so they distribute it out, and then when they get the 5x, right, then they're able to distribute the 5x all the way through, and the negative 2 all the way through, right? And then you've got 15x cubed, 1 plus 2 is 3, negative 25x squared, 1 plus 1 is 2, 4 times 5x is plus 20x, negative 2 times 3 is negative 6x squared, negative is a positive 10x, negative 2 times 4 is negative 8. And then we combine like terms. Here we have an x cubed. Here we have 2x, sorry, that's not like term of anybody, is it? We have a x squareds, like terms, and then of course we also have x's that are like terms, and we add those guys. The x squareds go together, the x's go together. Okay? So that we get this 30x from the x's, and we get negative 31x squared. And then this just comes straight down, and the negative 8 just comes along. Okay? Now there is a second method for multiplying more complex things like this, and that is to actually rewrite this guy underneath 5x minus 2 and create kind of like you're doing long multiplication way back in elementary school. So 4 times negative 2 is negative 8, and then negative 5x times negative 2 is plus 10x, and then 3x squared times negative 2 is negative 6x squared, and then you come again, 4 times 5x, there's no constant, so this is kind of like where you put the 0 when you're doing long multiplication. 4 times 5x is 20x, and negative 5x times 5x is negative 25x squared. Put that plus in there. And then 3x squared times 5x is 15x cubed, and then you add everybody together. All right, need a little thinner here. 15x cubed minus 6 minus 25 is negative 31x squared. 10 and 20 is plus 30x minus 8. So that's another way to do it. You get the same answer, obviously, and I'm good with either way if you need it. Okay, but then there's a special type of multiplication that we do with polynomials often, which is multiplying two binomials together, and that's called the FOIL method. Right? You guys have probably heard this before. FOIL represents the first two terms, O represents the outside two terms, I represents the inside two terms, and L represents the last terms of each binomial. And so that's what FOIL stands for, F-O-I-L. There's 4 combinations of things that you can multiply when you have two terms and two terms. Remember, binomials have two terms. And so if you have 2 and then another 2, you can have 4 combinations of those guys when you multiply them. And so it looks like this. All right, you multiply the first two terms. FOIL first is 7x times 4x. That's the first two terms, and you see right here, that's what you get. Then you do the outside terms. All right, the outside terms, here's the O. All right, for the outside terms. And then you have the inside terms. Make sure you take care of the signs with those guys. Here's the inside terms. All right. And then you have the last two terms as well. And so this is often how we kind of write it when we're drawing it out, but you can even break it down better like they did. And then when you take the first, outside, inside, last, the inside and the outside have the same x, right? So they're like terms, so you can combine them and get 28x squared minus 41x plus 15. And I know you guys know how to do this. Like I know coming out of high school, or no matter how long it's been, FOIL is something you've probably, right, can do in your sleep. You just have to be really careful with the powers. But the reason that I'm spending so much time on FOIL right now is because when you begin to factor, and a lot of algebra is factoring, and a lot of students struggle with factoring, and I know this, and so I want you guys to be ready, because when we do factoring, factoring is just undoing the FOIL method. It's just going backwards with the FOIL method. And so if you understand the FOIL method super well, then factoring is not as bad. Okay? And we'll talk about factoring here in the next section. Okay? So there are some special products that happen when you FOIL out a plus b and a minus b. What happens when you multiply these out, you get a squared here, and then when you do the outside terms, you get minus ab, but then the inside term is what? Plus ab. And then the last two terms are minus b squared, and so you get a minus ab and a plus ab, and they cancel out. They subtract away, and you're just left with a squared minus b squared. It's called the difference of squares. Okay? And we also have these perfect square binomials. Be careful. The thing I want you to notice here is when you have a plus b or a minus b all squared, remember that a plus b squared is not a squared plus b squared. That is not how it works, not at all. But when you have a plus b squared, what does that mean? That actually means you have a plus b times a plus b, and so you have to FOIL. I need you to remember that, because this is a common mistake that happens. I even have kids in my calculus class making that mistake because they just didn't ever get it. And so you need to put that in your head somewhere, that that's definitely not okay to just distribute the square. There's no such thing as distributing the square across a sum. All right. So I don't care if you memorize the squaring the binomial. You should know this term for sure. This product of the product of the sum and difference of two terms. In other words, the difference of squares here. You should know that one though. But these guys will just come out in the wash if you do them. So it's no big deal. Okay. So see how it works here. If you know it's a product of 7x plus 8 and 7x minus 8, that's the difference of squares multiplying a sum and difference of two terms, then you can just square them out, right? You don't actually have to do the FOIL method. You can just do the shortcut, okay? And that's great if you remember it. If not, just FOIL it out, because if you FOIL it out, you'll get 49x squared, right, minus 56x plus 56x minus 64, right? When you do the inside and the outside, you get these two guys and they subtract away and you're left with this anyway. So you don't have to memorize these formulas, not for now, but working backwards, it's certainly easier when you're factoring to know those formulas for sure. Okay. And now we won't do a whole lot with this, but you should be familiar with it. When you've got polynomials with more than one variable, so an x and a y, say, then remember that you've got to have like terms before you can add them, which means they have to have the exact same x power and y power both. A is still the coefficient, all right, and the degree, all right, you know the degree is the highest power of x when it's a polynomial. Well, the degree of a polynomial in two variables is the highest degree of all of its terms. In other words, if you add n plus m together, that's the degree, okay? And so if you want to subtract two polynomials with different variables in them, then they've got to be exactly the same. 4x squared y is the same like term as 6x squared y. Y cubed is the same as y cubed. X cubed is the same as x cubed. But there is no 5x squared over here, or excuse me, xy squared over here. And so you can't do anything with that. That just has to come along the whole time. It never gets joined because there's nobody else to join it to. All right, and the x cubes end up canceling each other out. So anyway, it's pretty straightforward. You guys just need to do a lot of practicing. FOIL method still applies if you have a binomial, and a binomial doesn't matter whether these are constants or whether these are y's. When you FOIL it out, see what happens. You get y's and x's both, and then you have this middle term that is still an xy term, so you can combine those two here and get that to be 25xy. But again, this is not anything really fancy or surprising. So take a look at the problems in my math lab. Take a look at the practice sheet in your course worksheets folder. And this just takes practice, guys. And again, most of you guys can probably knock this out real quickly, but I want to make sure that we're all on the same page. And as we're beginning to go through this process for college algebra, these foundational things, don't dismiss them. Don't be like, oh yeah, I know how to do that. I know how to do this, blah, blah, blah. Don't do that. All right, you need the practice. It's been a little while, and you need the practice to make sure that we're building on a solid foundation. Okay, so trust me on this. Take the time to do it. It shouldn't take you that long. And as always, shoot me an email if you have any questions. All right, thanks. See ya.